Welcome, Hornets, and thank you for joining me today. This is part 2 from assignment number 9. This is found on page 394, and I'll be working with numbers 21 through 23, and then 29 through 43 odds only. So let's go ahead and take a look at number 21 first. Number 21 is asking us to find our equation in the form of y equals ce to the kt power, and we are given 2 points on a graph. So they give us this exponential growth right here. They tell us that we have the point at 0, 1/2, and they tell us we have a second point at 5, 5. So we're going to go ahead and in number 21, we're just going to start. Using this equation, if I know I have 1/2 equals ce to the 0 power, 1/2 has to equal c. This gives me y equals 1/2 e to the kt power. And I'm now going to put in the 5 and the 5. 5 equals 1/2 e to the k times 5. And I can now simplify to get 10 equaling e to the k of 5k. Natural log of 10 is equal to 5k natural log of e. Therefore, the natural log of 10 has to equal 5k. This gives me my k value is 1/5 natural log of 10 equaling k, and I can now find the equation as y equals 1/2 e to the t divided by 5 natural log of 10. And that's what we're looking for in number 21. Let's go ahead and take a look at number 22. Number 22 is giving us a graph, and this graph shows that we have a decreasing function, so we're looking at a decay. I have the 0, 4 here, and I have another point off to the right at 5, 1/2. Now, this 0 is our constant, so if I have y equals ce to the kt power, I know that I'm looking at y equals 4 e to the kt power. Plugging in 1/2 equals 4e to the 5k, excuse me. I end up dividing, and I get 1/8 equals e to the 5k. Therefore, the natural log of 1/8 is equal to 5k natural log of e, which is just the natural log of 1/8, equaling 5k. I'm now going to divide both sides by 5. I end up with 1/5 the natural log of 1/8 equaling k, and I can now write my equation as y equals 4e to the t divided by 5 natural log of 1/8. This is my answer. We now go to number 23. Number 23 gives us a graph. The graph is also a decay, but it no longer gives us that first value. It gives us a 1/5, and it gives us a value of 5, 2. Well, we're still looking at y equals ce to the kt power. We just have a 1 and a 5 that we'll be plugging in. So a 5 equals ce to the k power, and 2 equals ce to the 5k power. I can take one of these and solve for c. 5 over e to the k has to equal c, and then I can put it right in here. This is going to create 2 equals 5 over e to the k times e to the 5k. Now I can go ahead and subtract so that I have 2 equals 5e to the 5k minus k using my laws of powers. This is giving me 2/5 equaling e to the 4k, which I can now work with the natural log of 2/5. I'm going to divide by 1/4, and I will then have k. Now, be aware that with this, I'm going to need to go back and figure out what is c. After all, according to my information, I would have 5 divided by, so I'm going to find out what that constant is. So let's just take a look. And let's do it this way. So 5 equals ce to the k power, which is 1/4 natural log of 2/5. And this will give me 5 equal to c 2/5 to the 1/4 power, multiplying the 4th power on both sides. I'm looking at 25 times 25 is 625, equaling c times 2 to the 5th. So we're going to end up multiplying by 5. Jeez, this is a little bit of a large number now, isn't it, people? Well, would have been better if I have a calculator. I'm just going to go ahead and I'm going to put it in right there, and I'm just going to go 5 divided by. So I have 5 divided by parentheses 1 divided by 4 natural log of 2/5. This is the easiest way to find it. It allows me to avoid all of this stuff on that side, and hitting enter, I get my constant is, or my C value is negative 21.827133336. Therefore, my Y will equal negative 21.827133336 times e to the t divided by 4 natural log of 2/5. And that's my answer. Now keep in mind, they're never going to ask you anything like this on the AP test, simply because this is Algebra 2, okay? This is nothing. Let's go ahead and get to the real stuff. That means we have to first practice numbers 29 all the way up through 43, odds only. So we're going to start off with 29. 29 says that we're looking at this radioisotope. It has a half-life of 1599. This is my half-life. I am given a quantity, the initial quantity. The initial quantity is 20 grams. They're trying to ask me how much do I have after working with this for 1,000 years and then 10,000 years. And we will have to use our calculator for this, so just be aware. So we're going to start off with number 29. And the first thing that I recognize is that I know I'm working with y equals ce to the kt power, and I know that I have y equal to 20 e to the kt. Now we have a half-life, and that means that it's going to take a certain amount of time for me to be able to get half of this. So 10 is equal to 20e to the k times 1599 years. I'm now going to divide. I get 1/2 natural log, and I'm dividing by 1599 is my k value. So I now know that I have y equals 20 e to the power of t divided by 1599 natural log of 1/2. I can now plug in 1,000 and 10,000 to find this, and I'm plugging it directly into my calculator. So that's what's happening. I have 20 times the power times e to the power of the fraction. Let's just do 1,000 divided by 1599 natural log. Now remember, order of operations is going to follow, so don't worry about parentheses. Just hit enter, and it will take approximately 12.96488 years. We're going to follow the exact same thing. I'm just going to go second enter, and I'm now going to insert another 0. Second delete, 0, enter. I end up having this is the amount of grams, not years. So we have grams, and I have 0.26206 grams. And these are the two answers that we're looking for. So you'll notice we start off with our initial condition, we plug in the information for the half-life, we find what that constant is, and then we plug in 1,000 and 10,000. Number 31. Now keep in mind, they're all doing the same thing. We still have the half-life of 1,599 years, 1,599 years. We know that after 10,000 years, I have 0.1 grams. So that's what I'm going to have to work with. So we have y equal to CE to the KT power. We know that we're looking at an unknown amount, but we have 0.1. And we know that we had CE to the 10,000 K. And we know that if I have half-life, then if I had 2 grams, I have 1 gram, and it took 1,599 years to get that. This is what's going to give me the K that I'm going to place here, that will allow me to find C, that will allow me to find my equation. Okay, so here we go. We're going to start off with the 1/2 natural log 1 over 1,599 equaling K. Notice it's the same thing. So we have 0.1 equals CE to the 10,000 divided by 1,599 natural log of 1/2. So I'm going to go ahead and I'm going to divide 0.1 by e to the 10,000, 1,599 natural log of 1/2. This will give me C. Here we go. 0.1 divided by, and I'm making sure that I have everything into the parentheses just to make sure. Shouldn't matter, but I want to be careful. 10,000 divided by 1,599 natural log of 1/2. And I end up getting my constant is 7.631573771. So I now know that I have y equal to 7.631573771 times e to the t divided by 1,599 natural log of 1/2. Now I can plug in 1,000 and I can plug in 0, and that will give me my initial quantity, which I already have. Alrighty, so let's go ahead and plug in 1,000 years. Now keep in mind, I can do second enter to get that last answer, then do times e to the power of, and I have 1,000 divided by 1,599 natural log of 1 divided by 2. Enter. And I end up having, after 1,000 years, I will have 4.9471228 grams. We know our initial amount, and we know our 1,000. Notice I'm just doing the same thing over and over and over again. So we're going to do number 33 next. 33 is giving us a different half-life. We now have carbon-14 with 5,715. That means that our constant is going to have to be 1 over 5,715 natural log of 1 divided by 2. Now, this is following the exact same pattern that we saw on number 31 and 29. We also know in 33 that we have 5 grams, so 5e to the t divided by 5,715 natural log of 1/2 is y. There's my equation. I'm now going to put in 1,000 and 10,000, and I have my answer. 5 times e to the power of 1,000 divided by 5,000, 715 natural log of 1 divided by 2, and I end up getting 4.42890474 grams. And I'm now going to find out what it is with 10,000 years. And I have, after 10,000 years, 1.486734 grams. We're now going to take a look at number 35. This gives us plutonium-239. So that was 33, 35. If I have plutonium-239 with a half-life of 24,100 years, I know my constant is 1 over 24100 natural log of 1/2, following the exact same pattern. So y equals CE to the t divided by 24100 natural log of 1/2, and they tell me that I have 2.1 grams after 1,000 years. So 2.1 is equal to CE to the 1,000 divided by 24100 natural log of 1/2. Now I'm going to divide. So I'm taking 2.1 and dividing by e to the power of 1,000 divided by 24100 natural log of 1 divided by 2. And I'm getting approximately 2.161275 is my constant. Let's go 75677 is the constant. So y has to equal 2.161275677 e to the t divided by 24100 natural log of 1/2. I'm now ready to go ahead. Since I have my constant, it's time to find out what 10,000 years is. So second, let's try second negative, gives me the answer. I'm then going to go e to the power of, we want 10,000 years, so 10,000 divided by 24100, natural log of 1 divided by 2, and my answer is 1.6210688 grams. That's that's that first group. We're now looking at number 37. Number 37 is a word problem. It says radioactive radium has a half-life of approximately 1599 years. What percent of a given amount remains after 100 years? So I'm going to start with one whole, and I have e to the t divided by 1599, natural log of 1 divided by 2 equals y. And I'm now going to find out how much of that one whole we have after 100 years. So I have y equals 1e to the 100 divided by 1599 natural log of 1 divided by 2. This will give me a decimal less than 1, and I can convert it into a percent. So here we go. 1 times e to the power of 100 divided by 1599 natural log of 1 divided by 2, and my answer is 95.75%. So since I get y equal to approximately 0.957577, I know that we will have approximately 95.7577% of our original substance remaining. Alrighty, that was number 37. This brings us to number 39. We have very few left. So number 39 is asking us to complete the table for savings account with compounded interest continuously. Please remember that the compound interest is the amount equals your principal e to the kt power. So we're doing the exact same thing. This is an annual rate. So we're looking at having $4,000 as our initial investment, e to the t times 0.06. And let's just make sure. Don't forget your t, and this is how much we have. So let's just kind of figure this out. To double. In order to double, that means that I want 8,000 equals 4000 e to the t times 0.02. This is giving me 2 natural log, and I have 1 over 0.02 equaling our t. Alrighty, so what do we have? 1 divided by 0.02, natural log of 2, and I should get approximately, 34? Oh, hang on, that shouldn't have been 0.02, it should have been 0.06. Excuse me, everybody. And let's try that again with that 0.06. I don't know why I did it at 0.02, but hey, and there we go. I end up getting approximately 11.552453 years to have my amount doubled. How much will it be after 10 years? So we're now going to plug it in, and I have 4,000 e to the power of 10 times 0.06. And I end up with approximately $7,288.47.5. Okay? And now I'm going to go to number 41. Number 41 is just following the same pattern. We have amount equals PE to the KT power. We know it's going to double. So 2 equals e to the, doubling times 7.75k. That'll allow me to take the natural log of 2 and divide by 7.75, equaling rk. So we have the annual rate for number 41 is going to be the natural log of 2 divided by 7.75, and I'm getting a rate that is approximately 0.089438, which we would translate to 8.9438%. So that's my annual amount. We're now looking for how much after 10 years. So we're going to put it all together. We have 750 as our initial value. We have E, and we're looking at, I'd better write the largest decimal I can if I'm going to use it. Otherwise, I want to use that. Frankly, that's what I would prefer. T natural log of 2 divided by 7.75, equaling our amount. And now I'm going to find out after 10 years. So I have 750 times e to the power of 10 ln of 2, close parenthesis, divided by 7.75, and I end up with approximately $1,834.37.05 after 10 years. And that is number 41. Okay? Alrighty, Hornets. That's it for the for assignment number 30 for number 9. The only one I haven't done is number 43, and I leave that for you to do. Okay? Thank you very much. I hope this has helped. If you have found this to be a helpful video, please remember to click like. If not, please remember to give me comments and suggestions on how I can improve. Thank you very much. Be safe, be well, and take care. And thank you very much for listening. Bye-bye, Hornets.